So, oh yeah, question? All right, so today we're going to continue our work with models and applications, word problems, but this time we're going to use two variables. And things that are coming up, we've got next week an in-class quiz, and the following week is our first test. Okay, so just keep those things on your radar. They are coming up. All right, I'll send you back to work on the preview exercises at the end of class if there's time. Now we're just going to jump to the teaching demo. All right, systems of linear equations in two variables. The examples we've worked so far have been using one linear equation and one variable, though many of you used this technique in the activities yesterday. Many of you used two variables last class, and I didn't stop you because it's a totally valid approach. I just wasn't going to present it until today. Okay? So today we're going to review how to solve problems, create and solve systems of linear equations in two or more variables. So this graph down below here, it represents the system of linear equations x plus 2y equals 142 and negative 3x plus 10y equals 160. So where the equation negative 3x plus 10y equals 160, it models the percentage of never married US adults, right? And the equation x plus 2y equals 142 models the percentage of US married adults. So never married and currently married are the two different equations. So we're going to estimate the coordinates of the common solution, the intersection point for this system of linear equations. Where do you think that point is? Give me an estimate. 68, 37. Yeah, that's good. 68, 37. And what does that intersection point tell us? Okay. So remember, x is representing time. X is representing years since 1970, and y represents percentage, right, of either never married or currently married US adults. All right, so 70 or 68, so that's representing years after 1970. So 68 years after 1970, when is that? 2038, yeah. So in 2038, what are we saying here? What is the 37 tell us? 37%. Yes, there will be an equal number of never married and currently married US adults. They'll both be at about 37%. Okay. Okay, so until then, right, up until the year 2038, the married line is above the never married line. So the percentage of married people will be greater than the percentage of never married people up until 2038, when they'll be the same, and then they switch, right? Or that's our prediction right now based on the data we have. Then they'll, in 2038, after 2038, it will switch so that currently married people will comprise a smaller percentage of the population than never married people. All right, so the solution to the system of linear equations was found visually by graphing. However, we could only approximate the solution. We had to kind of like look at this and go, well, it's not quite 70, not quite 40, and kind of guess what the numbers were. So next we're going to review two algebraic methods. One's substitution, the other one's addition, or also it's called elimination. that allow us to find the exact solution for a system of linear equations in two variables. All right, so same two equations, we're going to use the substitution method. So with the substitution method, you start by picking the simpler looking of the two equations. Which of these two do you think is simpler, top or bottom? Top. Okay, so I'm going to start with the top equation, x plus 2y equals 142. I'm going to solve for one of the variables in that equation. X is going to be easier to solve for because it has no coefficient, right? So it's only going to take me one step to solve for x. So x is 142 minus 2y. So I just subtracted 2y from both sides. Okay, so now I use my other equation. Now I write down my other equation, negative 3x plus 10y equals 160. And wherever I see an x, right, wherever I see an x, I'm going to replace it with 142 minus 2y because x and that expression are equal. They're the same. So instead of negative 3 times x, I'm going to do negative 3 times 142 minus 2y plus 10y equals 160. And from here I solve. Okay. So I'll just distribute my negative 3. All right, negative 3 times 142 is negative 426 plus 6y plus 10y equals 160. All right, I'm going to add 426 to both sides. So I'm going to get 586. And then add my 6y and my 10y, so I get 16y. Divide both sides by 16. And y is 586 divided by 16, 36.625. And our estimate for y in the previous example, right, when we did it graphically, our estimate for y was 37. For the y coordinate was 37. So we were pretty close. But the algebraic method gives you the most exact. And then once I have y, I can go back to my equation for x and figure out x. 142 minus 2 times 36.625. Just replace the y with the number that you just got, and you get x is 68.75. And we had estimated 68, so we were pretty close. Is this familiar? Everybody's like seen this once or twice? Okay, good. All right, so our other method is the addition method. You may also know it as the elimination method. I'm going to copy down my two equations. X plus 2y equals 142. And negative 3x plus 10y equals 160. All right, so we have to choose a variable that we are going to eliminate. So the goal is that we're going to add the two equations together and get one of the unknowns to cancel. All right, so which variable, which unknown do you want to eliminate? X. Okay, so right now, if I just add these two equations together, x plus negative 3x would be negative 2x. I'd rather it be 0x. I don't want to have any x's left. So look at this top equation. What should I multiply both sides of that equation by so that it'll cancel with negative 3x? 3. Multiply every term on both sides by 3. All right, so, and then I'm going to rewrite it underneath here. So I'm going to get 3x plus 6y equals 426. Okay, now looking at these two equations, I'm going to add them together. My negative 3x and 3x, those cancel. 10y and 6y make 16y. 16y equals 586. Divide both sides by 16, and you get y equals 36.625. Same answer as before. And once you have y, how do you get x with this method? Substitute into which equation? What? Either one. Yes, trick question. You can use either equation. So I usually just pick the simpler looking equation, but you can pick either one. So start with x plus 2y equals 142. Replace the y, x plus 2 times 36.625 equals 142, and then solve for the x. And you're going to get x is 68.75. Does that look familiar? People have seen that before? Okay, that's called the elimination or the addition method. All right, so we're going to solve a dual investment problem. You did one of these last class, right? But you did it, most of you did it with one variable. Some of you did use two. And we're just going to go through officially how to use two variables to solve this problem now. All right, a scholarship fund has $10,000 in it. We can invest in two funds. One is lower risk and one is higher risk. From the low risk fund, we can expect to earn 4% annually. And from the high risk fund, we can get 8% annually. We want to have an expected return of $550 per year, but we want to put as little money in the high risk fund as possible, right? So this is how scholarship funds work. Usually somebody makes a donation of like $10,000, and then that $10,000 is invested, and they use just the interest to give out a small scholarship every year, right? They'll just put that $10,000 in an investment, and they want to give a $550 yearly scholarship. So that $10,000 funds the scholarship forever, right? But we want as little money in the high risk fund as possible because we don't want to lose our initial investment of the $10,000. So we can solve this problem using one linear equation and in a one variable or linear system. So your text demonstrates how to use one variable to solve this type of problem, but we're going to look at two variables today. Some students find a table helpful for setting up these dual investment problems. You can also use them for other kinds of word problems, distance, rate, time, mixture problems. So we'll just do one for this. Okay, so in my lower, we need to define some variables first, right? So we're going to have two variables. Let's say let x be the amount invested in the low risk fund. And y, that's the other amount we're looking for. Y will be the amount invested in the high risk fund. Right, so I'm just going to put x and y into the two appropriate boxes. Okay, the amount we invest at the lower rate and the higher rate. And what's our total? $10,000. So I'll put $10,000 in my total investment. My percent interest for the lower rate, the lower risk is 4%, and the higher risk is 8%. They didn't tell me what kind of interest I want on the whole thing. So I'm just gonna leave that blank for now. It wasn't given. And then let's look at how much interest we want to earn. How much interest do we want to earn in total? $550. All right, so I'm going to earn some of it in my low risk fund and some of it from my high risk fund. I'm going to combine the two to make $550. So how do you figure out, based on how much you invest and an interest rate, how do you figure out how much money you make? Say it louder. You multiply, yeah. So that's how interest works. You take the amount you invest and you get a percentage of it, right? So you earn 4% every year. So at the end of 1 year, you just take your percent, multiply by the amount you invested, and that's the interest that you make, 0.04x. And then you do the same thing for the higher rate, 0.08y. From this table, I need to be able to write two equations, because if you have two unknowns, you need two equations to either use substitution or elimination to solve it. So I need to come up with two equations. This is going to give me an equation. How can I look at that column and come up with an equation that relates those? Yeah, x plus y equals 10,000. Right? The amount that you invest in the low risk plus the amount you invest in the high risk has to come out to a total of $10,000. And then I've got this column over here. How can I relate these quantities in it with an equation? Add them as well, yeah. This is the interest you earn in your low risk fund. This is the interest you earn in your high risk fund. You want to make sure that you can combine those to make a total of $550. So my other equation is 0.04x plus 0.08y equals 550. And then I'll let you solve it using your favorite method when you have an opportunity. I'm not going to finish. I'm going to have you jump into your class activity, do some practice solving problems using two equations, two unknowns.